Hi everyone, thanks for coming here. If you're here for those 18 plus talk, it's not that one. So I'm going to talk about something else. So my name is Soroush and I work at NCC Group. I'm a web application tester and I'm good at breaking stuff. I have created a few tools, but I've broken more. I also love to bypass blacklist protections. And it is especially good when I can mess with an application and bypass the whole blacklist with one single character. If you want to contact me, that's my Twitter handler. So in today's talk, I'm going to talk about HTTP, especially HTTP version 0.9, 1, and 1.1. And I'm not going to talk about HTTP version 2. So today, basically, we are going to smuggle some HTTP requests to the server. And how we are going to do that is via mutation. So we are going to mutate a HTTP request to another HTTP request, and we want to deliver it to the server. So this talk is going to have a lot of HTTP requests, some boring, a few interesting, and you will see some new things in it as well. And I think they are new, as I couldn't find them anywhere else. So in order to mutate requests, you need to know what you're dealing with. From one web service to another, from one proxy to another, from one technology to another, and also from one version to another, it can differ. So you need to really know what you're going to deal with. Also, different WAFs act differently. So we have to have a database of all different mutations, all the characters, all the patterns we can use. Then we can actually create our own requests and we can go through the WAPs, hopefully. So in my own lab, I had 10 VMs with different web servers and different technologies on them. And I started to just test web servers first, before testing any WAFs, any proxies, or anything else. So I identified a few number of anomalies, something that shouldn't be there, and then I started pointing at different WAFs, and I realized that it can really go through. And I'm going to discuss that today. So about the HTTP. So I'm going to talk about HTTP version 1.1, 1, and 0.9, just because they are textual. HTTP version 2 is in binary, and I'm not going to talk about it today. Hopefully later I can talk about it, in future. So HTTP version 1.1 has 3 RFCs. The latest one, I think, came in 2014, I think, around that time. And it is actually multiple RFC thing. So if you want to really read about it, you have to read multiple RFCs. But then the good thing about HTTP 1.1 is because it has different RFCs, if you start reading from the first one, you will realize that the changes are not really applied on the web servers. Some changes are applied, but not all of them, and that's when you can actually find a bypass. With HTTP 1.0, it's basically very similar to 1.1. There are a few differences and big changes, but I'm not going to talk about all of them today. And with 0.1, basically, it's very old. It is ancient, around 1990, 1991. It came out at that time. Okay, it is younger than me, but in technology, it is actually very old. So Windows 3.1 is actually younger than HTTP 0.9. And you will be surprised that still today, HTTP 0.9 is being supported by the web servers. And you may have not realized that you have used HTTP 0.9, but you have probably seen it if you have tested web applications. You have seen it when, for example, you have messed with content lengths, and content lengths of the request you are sending to the server is actually shorter than the body of that request, or like in a post request, it's actually shorter. You send it to the server, and then you will realize you have 2 responses, and the second response is something like the verb is invalid. In that, you have actually sent 2 requests to the server, and one of them was HTTP 0.9, which is actually just one line of request, and it must be GET requests. So here is a simple HTTP request. As you can see, we have a path, then we have query strings, then we have host, we have cookies, and headers, and then the post body value. We can have many more. So we are going to basically discuss this today. We are going to talk about it further later. So about the request mutation, I'm going to show you that I can change request A and make completely different request, which is request B, but from web application point of view, request A and B are the same and are going to give us the same response. But from WAF's point of view, or anything in the middle, they are completely different. So how can this mutation actually solve any problems? So for example, you're in your office, Facebook is filtered, you can use it and see your Facebook while working. Yeah, it's not a good practice, but you can do it. You can browse your betting sites. You can basically bypass some protections. /admin is filtered from your location. By mutation, you may be able to bypass that and see /admin. Also, because web servers, proxies, other technologies are going to respond differently, what would happen is you can fingerprint them using this mutation. Also, there are cool research around cache poisoning, response splitting, and socket buffer poisoning, which is actually new to me. Not very new, but I've seen DEF CON 24, I think there was a talk about it, and it's actually pretty much cooler than other talks that I've seen about HTTP. But I'm not going to talk about that. I'm going to talk about WAFs, because they are very popular. You have seen it during pen tests. So for example, when you're doing bug bounty program, if there is a WAF in front of you, it's actually very bad, because you really don't know if you're hitting the web server properly or not. So you send a request to your web server, and WAF is like, no. So yes, so we are going to bypass that. We are going to bypass this restriction. So for example, you are testing a web server, and you have a WAF in front of you, and you think, okay, I have no time to ask for permission to actually access that. I'm saying this, however, after this talk, probably WAF companies are going to block many of these anomalies, but there are a lot more than that. And hopefully, we will have a powerful WAF. And by saying that, because OWASP top 10 now supports like having WAF, now WAF companies now like, they're very cheerful about it. They are saying, okay, now you need WAF, you need to buy our product. But now they have to think about it. If I find a bypass in your WAF, it is not basically a missed feature or something like something that you need to improve. It is now a vulnerability of your product. They need to be responsible for these bypasses, which is pretty cool. So let's begin. Let's start bypassing a WAF by mutating a HTTP request. So common mutations, you have heard of them. Probably you have even used them. So in a HTTP request, headers, values can be on the next line folding, as long as they start with a space character or a tab character. They're basically the same. So for example, you can have host : your example.com in the next line with a lot of spaces and tabs before them. Maybe it will bypass something, but they're well documented in RFCs. So I don't think you can bypass powerful WAFs with them. Also, other common behaviors, for example, you want to access /admin, and a /admin is blocked. You put something like a /foo /admin, and now you can access it. I don't think you see these things anymore, because WAF companies are basically blocking anything that they know can be dangerous. Most of them are based on blacklists, and we are going to talk about these blacklist protections today. And I will show you how we can actually go through these WAFs. So, strange mutations. So there are behaviors of any of these web servers that have surprised me. I've tested a lot of things on them, and these are the things that I didn't know. There are a lot more, but I could only fit these in this one slide. For example, ampersand character could be replaced by a semicolon in a Python Django web application. So basically, in your query string or in your post body, you have ampersand. You can just replace that with semicolon. So if there is a VAF that is actually looking for some parameters, now from their point of view, probably that parameter is not there anymore. It's basically a lot of things with semicolons. And for a PHP application, Apache, they basically, you can send any HTTP verb you want to them. You can just send foobar, you can send anything you want, rather than sending a post request. You can just change that post to foobar, and it will work normally if they don't have any more protections. ASP Classic is even worse. You can basically put person character in the middle of it, and it doesn't care as long as there is no two hex characters immediately after person character. It will ignore that person character completely. Also, what ASP Classic does is it will convert some UTF characters to ASCII characters. It's basically pretty much random. I found a bypass for NoScript a while ago about this, and he basically, the author of NoScript, patched it and called it XSS homology or something like that. So basically, XSS, I can't say it, but if you search it, you will find it. It was an offensive word, but at the same time, it was basically a good research on that. On Apache Tomcat, anything after semicolon in the path will be considered as a comment. So for example, you can even start putting a semicolon before the first slash in your HTTP request, and it will be ignored. So you can have this path 1, semicolon foo, path 2, semicolon anything else, slash semicolon. It's exactly the same as path 1, path 2. So if you have a VAF that actually cares about the full path and something like, and then a slash, then it's going to be bypassed when it sees this. And something very strange, Apache Tomcat actually has done something that is actually against RFC, against HTTP RFC. With HTTP 0.9, you can only send a GET request in one line. But with Apache Tomcat, you can send a POST request. You just need to remove the HTTP version from it, and then it will work. And it will see all those headers, it will see your POST request, and basically from your WAF point of view, it's just a weird request. So let's start with that. For this talk today, I have chosen iOS 10, ASPX, and I'm going to work with that. So some of the mutations here are going to work on other web servers, and but some of them are not going to work, and they are especially for ASP.NET on iOS 10. So even if you try some of these on ASP Classic, it may not work, but we have other solutions for them, and I'm going to talk about those later. So this is a normal POST request, and it has a SQL injection payload in input 1. Normally, if you send something like that to anything that has WAF in front, you will get an error that says 403 or forbidden or something like that. The request will not hit the web server. We are going to mutate this request now. In the next slide, so these slides are like this. The red ones are the ones that I am going to kind of like, okay, this one maybe it's not like that, but I'm going that post verb on top first. So I have changed that to get, and I have added content type header. From ASP.NET point of view, it's still a post request, and we are going to and now actually I haven't added the content type. Sorry, I'm going to change the content type in the next slide. So I've changed post to get, and in the next slide I'm going to change the content type. So I'm going to change the body type to a multi-part form data, which is completely normal. This is standard. You can do that in .NET. Post request can be converted to, the content type can be converted from basically URL encoded to multi-part form data. So this is completely okay. But on the next slide, I want to show you that that red part, form data semicolon, also those dash characters after the last one, the last boundary you see, can be removed as well, which is basically against RFC, and it's going to make the HTTP request invalid. But still, from ASP.NET point of view on IIS, it's completely fine. You can do that. It doesn't matter. It will accept it. So on the next slide, I'm going to add useless stuff to this HTTP request to just make it a little bit more confusing for the web and for the WAF. So I've added another boundary on top, and I have added semicolon file name. That space between file name and equal sign is intentional. If you don't put it there from IIS point of view, .NET on IIS, it's a file request. But now it's still a post request, so you need that. And if you look at this request closely, you can see that the double quotation hasn't been closed. There is a reason for that. Some WAFs can be bypassed simply just by doing that. And the boundary, I put my name there, but like my Twitter handle there, but I could have put something else. I could have put 2, and then I could have added some rubbish later with 2 to this request to confuse WAFs even further. So on the next slide, what I'm going to do is this. I have converted this request, which is completely readable. As you can see, I still have that SQL injection. Some WAFs still can be bypassed just by this. You don't need to mutate it. But we will mutate it, and I have basically encoded the request to the server. I haven't seen this anywhere by searching in the internet. Perhaps some other people have found it, but I think that's something new. So in here, I've used IBM 037 encoding. From IIS point of view, it's exactly the same as the previous request. I have encoded all this message, as you can see. And as you can see also in the query string, the message can be encoded. So how did I do that? How did I encode it basically using IBM 037? How can you do that yourself? It's very easy. You can just use Python. You can use anything else, but Python was very easy. So as you can see, I wanted to encode content dash disposition name input 1, and then that file name. This actually I had to remove that double quote in the end, but that was a mistake. But anyway, you can get the idea how I have actually encoded this. And after you URL decoded it, it will be like that. You can keep it encoded in the request. Other web servers are different. The only web server, so I have tried this on Python Django, it works. In Python 2, I think you need to send them decoded, URL decoded. In Python 3, you have to encode them, URL encode them, so you can send them in this format to the server. Apache Tomcat accepted the encoded messages only in post body, not in the query string. ASP Classic didn't even decode this, so it doesn't work on ASP Classic. And Apache PHP, this one was not loaded because you need to load some modules in Apache to decode messages. So effective on Apache Tomcat, IIS and .NET, and Python Django, which is quite cool. And for our purpose, it's enough. So now I want to convert this message to a chunked message. Basically, chunked messages are the same request. As you can see, you're still awake, aren't you? So that's good. So the chunked messages are basically the same HTTP request as before. I've only added the size of that part of the message in hex to the top of the request, as you can see. So A, for example, is like 10 characters. And that space between and before that 63, which is like length of the other bit of the body, is necessary for IIS, but on others, it is a little bit different. So that is also important to think about that. And you can basically have one character in one line. Even you can have some sort of like, even if you have URL encoding, you can keep one person in one line, and then you can have the numbers on another line. It is still going to, so the web server is going to convert this message to a non-chunked message, and then decode this message based on the encoding, the content type encoding. So if I had a URL encoded message rather than a multi-part message, I could have URL encoded the same request. But in here, I don't need to do that. So I've chunked the body that is completely nonsense from WAF point of view. And ta-da, I have added more stupid stuff to it. So basically comments after the length of the body, as you can see. I have even added some sort of like boundary to additional boundary to the request to confuse WAFs. You can do a lot of things here. You can even add more stupid stuff. I couldn't, just because I couldn't fit it in this slide. For this purpose, basically, it can bypass a lot of WAFs. And when I say a lot of WAFs, basically, I have tried it on some of the cloud-based WAFs, and it went through basically all of them. It doesn't work if the web server, or the WAF, I should say, has a whitelist validation. If it basically says, from my point of view, this HTTP request is nonsense, I'm not going to let it go. I'm going to deny that. If they do that, yes, that's going to be fine. But there are only a few WAFs that does that, and WAFs that do that. If, for example, a WAF does that, then the chance that it's going to block valid, legitimate requests is a lot higher. So it really depends, but I will suggest WAF companies basically reject all these nonsenses rather than using blacklists. So request A was this. Very simple, straightforward, and everybody can understand it, can read it. You can basically convert it to this nonsense, and it will bypass your WAF protections. So what next? It wasn't the end of it. You can still mutate it further. So now I'm going to talk about HTTP pipelining. So you have used Burp Suite. So who have used Burp Suite? Just, yeah, very good. So most of the people here have used Burp Suite. So when you're using Burp Suite has, for example, in repeater or other sections, an option to automatically update the content lengths. So if you want to use Burp Suite for this, you can. I'm not going to promise that you are going to see responses from HTTP pipelining, all of the responses. You will see the first one always. Sometimes you can get all the responses. But your requests are going to hit the web server. So in HTTP pipelining, we will send multiple HTTP messages in one single request. What it does is actually when you send that request, for example, I have content length 21. 21 is the length of input 1 equal to nothing to see. That's 21 character. After that, on the next line, I have the second request. You can basically continue doing that and have the third request and fourth request and go on. However, you have to be careful about it. If you have connection close, that's not going to work. HTTP pipelining only will work with keep alive, connection keep alive. Connection keep alive is default for HTTP 1.1, but for HTTP 1.0, if you don't mention connection keep alive, web server think that is connection close. And if this request goes through a proxy may say, okay, I need to rebuild this message. This is not one message. I have to basically dechunk it. And not dechunk it, but then I have to break it into multiple requests. Then it is between the proxy and the server to decide what they want to do. And proxy may say, I'm going to still send it as pipeline request, but I'm not going to tell the client what I'm going to do. So basically, connection header is hop by hop. If it goes through a proxy, then you may not be able to send multiple requests. But in a pen test, you can normally verify that by, for example, if you have something, for example, updating your name or something like that, a request that updates something, you can put them in two different requests in HTTP pipelining and hit the server with it and see if the changes in the second request has been applied to the website. And if it has, then it means that, for example, you have probably sent that request as HTTP pipelining. However, be careful about that. You may have proxy, and proxy may have sent those things separately. So another way of testing for that is another header that we have, max forwards. With that, if you set max forwards to 0, whenever it hits the proxy is going to say, okay, I shouldn't forward it anymore because I have to just respond that I have received it. Basically, it's like a time to leave thing for HTTP requests. We reduce the number. So what can I do with this? So with HTTP pipelining, I could basically send another HTTP 1.1 request or 1.0 or anything like that. However, it's basically very cool to send HTTP 0.9 here. Why? Because if you just send a HTTP 0.9, for example, using Burp Suite itself, in your first request, what would happen is that you are not going to see anything. You're just going to see empty response. The best way of doing that, if you are just going to send one single HTTP 0.9, is obviously using Python directly. I have created a tool for that to use socketing and to use for HTTP pipelining, for 0.9, for anything. And I will tell you about that later on as well, that you can use. So with this one, what am I doing here? So I'm sending one post request to that sample.aspx page, and then I'm sending the second 0.9 request to another page of the same web server with an input value. So if it is iOS, what it is going to do is, even if you put headers after that first line, it's going to ignore them. But if it was Apache Tomcat, then it was going through. So why is this interesting? HTTP 0.9 basically is awful. In the latest RFC, it says, we don't expect web servers to support this anymore. They can completely remove HTTP 0.9 support from their product. They haven't. So what would happen is a WAF, and so I had a WAF in my hand, and I was playing with this, that was blocking something like a /OWA that was for Outlook Exchange servers. So they were blocking their emails externally. So what they didn't think was what would happen if I sent HTTP 0.9. So it basically, when I sent it like this, it was like, oh, I can't even understand this. Let's just hit the server with that. So I got two responses. One of them was to their default page that I could access, /, and then the second one was to a /OWA and the file I wanted to hit. And actually I hit that. Obviously, it won't work for Outlook because basically you need to send a post request. But if it was something like a /admin /reset the server or something, it would have worked. My request would have gone through. And if it was Apache Tomcat, I could basically post a request to that server, so it would have been cool. So tips for mutating the HTTP requests. So be smart about it. Don't use all these things at the same time. Use them one by one. See, perhaps by changing the request a little bit, you can bypass the WAF. Don't burn all of your exploits on a WAF at the same time. Because what would happen is when you're mutating your request, the web server may say, oh, okay, hang on, I can see a null character here. I'm going to just deny everything. So, or WAF may say, okay, oh, this request looks crazy now. I can't let it go. But if you were just mutating it by one step, you might have bypassed it. So use this one by one and see how it is going to work. There are a lot more anomalies, and what we need to do is we need to just document them all. What I have found is there are a lot of different places that they have documented a few bits and pieces, but there is no one place to basically contain all these different behaviors of web servers, WAFs, and proxies. So what else here? So different technologies are different, obviously. So if you are trying something on iOS, it may not work on Apache Tomcat, or vice versa. So you need to basically know what you're dealing with first, and then you can hit it, and you may be able to bypass the WAF in front of you. Also, I found this situation that I sent, for example, a request to Fiddler, and Fiddler completely changed the request to something else. So basically, perhaps using Mutation, you can send a request that does something if it doesn't go through a proxy, and it does another if it goes through a proxy. So basically, you may be able to build some polymorphic requests that do different things based on their location. So what I have done here is I have registered this domain, http.ninja. I don't know why I could register it, but it was available and I got it. It was, I think, just 3 days ago. I have uploaded everything that I could in GitHub, and currently I have linked this website to that GitHub. But what the plan is, we are going to host as many things as we can, all these anomalies, all these different behaviors of the web servers there. So for example, when you are dealing with Apache Tomcat, you don't need to do all these tests yourself. Or when, for example, you have your own web server, like Jetty web server, or something like that, and I haven't tested it, or nobody else has tested it, you run a tool on it, and you get some results, and you can upload the results here for everybody to have, so they don't need to go through all these things, and then we can share all these cool things at the same time. The target is to have a framework, so then we can test WAF applications with. So obviously, what would happen is WAFs are going to bypass these things gradually. Block these things gradually. But that is for good reasons. So if WAFs can block bad requests, if we are making WAFs more secure, then that means the internet is going to be a safer place. Obviously, it's going to be very more difficult for us as testers to test a web application behind a WAF, but hey, we will find new bypasses. We will cover HTTP 2, and we will have a lot more things to work with. But then it's gonna keep grow, and we are going to have a better tools to play with. And for example, if you get a WAF in front of you, and someone says, "Okay, we have this product here that does block, for example, these things. Test it for us." And you won't scratch your head and say, "Okay, there are millions of things." You come to this website, look at it, and you will use the tool. You will run different things on the web servers and to see which ones are going to be blocked by that WAF, and you're going to report back. So we hope it's going to be good. Obviously, we need the community to help with that. We need different people to to test this on different applications, to work on this. And if people are going to, for example, upload spam data, things that are going to be false, for example, what would happen if I say, on IIS you can do this, but you basically can't? So we need to work that out. Something probably similar to Gareth Hayes' tool that works on the browsers. So we thought browsers are basically cool with, relaxed with HTML. Web servers are also relaxed with HTTP requests. So perhaps if we find all these things and document them, we can do a lot more than what we are doing currently. And thank you very much for coming here and listening. So if you have any questions, I can answer it now. No questions? Okay, thank you very much for coming here.